Welcome to my movie about types of mixtures. Today we're going to learn about two types of mixtures. One is called a suspension and the other is called a solution. First we're going to talk today about a suspension. You're going to need to pause the video to write this down. But a suspension is sorry, it looks like a 4-year-old wrote this. But a suspension is a mixture in which particles can be seen and easily separated. Think about if you put pepper in water and you mixed it up, the pepper would all just eventually separate and float to the bottom. So a suspension is something where the particles will eventually separate, like oil mixed with water, soot in the air, pollution in the air, chalk in water, sand in water. So a solution is a well-mixed mixture. For example, if you dissolve salt into water, you would get a solution where the particles would dissolve. You wouldn't be able to see them, but you would be able to taste the salt in the water. There are lots of kinds of solutions, not just a solid dissolved into a liquid. You could have air as a solution of a gas dissolved into a gas, oxygen, and other gases dissolved into nitrogen, or soda water, which is carbon dioxide dissolved into water, antifreeze, ethyl alcohol dissolved into water, or dental fillings, which used to be made by dissolving silver into mercury. And mercury is a liquid at room temperature, but eventually that would harden in people's teeth. They don't use that anymore. Or the alloy brass, which is zinc dissolved into copper. All right, moving on. We are talking about the words solvent and solute. So stop your video if you need to and write down the definition for a solvent. A solvent is the part of your solution that you have the most of. So generally speaking, if you're mixing salt and water, the solvent is going to be water because there's more water. It's the thing you have the most of. Now, water is called the universal solvent since it dissolves so many things. So if you think about it, there are lots and lots and lots of things you can put into water and they will just dissolve. And water is the solvent of your body. Your body is made of mostly water, and water is the solvent in most of your bodily fluid, like blood, tears, saliva, sweat, urine. All those things are solutions where the solvent, the thing you have the most of, is water. All right, so the next thing we're going to talk about is called the solute. A lot of people try to pronounce it the solute, but it is not the solute, it is the solute. The solute is the thing that you have the least of, the thing that is dissolved by the solvent. For example, when you have the water and the salt, the water is the solvent, the thing you have the most of, but the solute is the salt. That's the thing you have the least of. Okay, so salt does some pretty cool things. One of the things that salt does that's pretty cool is it makes water freeze at a colder temperature, and it makes water boil at a hotter temperature. Those are kind of opposites, I know, but it works for different reasons. So let's talk about the first one. It makes water freeze at a colder temperature. So if any of you have ever made ice cream, which we're going to do here pretty soon, you know that you use salt in the ice. Now cream freezes at a slightly colder temperature than water. So if you want cream to freeze, you've got to get a freeze just below ice. So putting your ice cream just in ice wouldn't work. So you've got to put your cream in salt and ice. And here's what happens. You maybe need to stop the video to draw your pictures. But first we have a picture of liquid water, molecules flowing around freely. And then we have ice where they're all lined up like soldiers. Then you have salt water, where you have all those liquid molecules, but these big chunks of salt in the middle. So imagine if you're a water molecule and you're flowing freely around the classroom, and the teacher comes in, she says, line up. And while you're trying to line up, she starts throwing a bunch of beach balls at you. It's really hard to line up with all those balls everywhere. That's what happens to the water molecules when there's salt in the way. They have to work harder to freeze, causing a slightly colder freeze and allowing the ice cream to freeze. Okay, so somehow I managed to completely delete the part of this page that had the writing on it, but that's okay, because this is all about why, if you're ever making spaghetti, your mother says, throw some salt in that water and it'll make it boil a little bit faster. So what the salt does, it doesn't make the water boil faster, it makes the water boil hotter. So here, of course, is, oh, I'm drawing in red, I didn't know that. Here's your pot, right? Of course, that's a pot. And underneath your pot, you have your fire. And inside the pot, you have your spaghetti. And you also have your water molecules. So here's your water molecules down here. There's one, there's one, there's one, there's one, right? Now, as these water molecules heat up, they turn into a gas. And where do they go? Whoop! Right up to the top, because the air is less dense than the liquid. Now enter those lovely NaCl molecules, right? They get in the way. And so this water molecule right here, this one, as it tries to go up, it's going to bump itself on that salt molecule and it won't be able to rise like it wants to. So the salt molecules get in the way of the water molecules rising as they turn into a gas, forcing them back down and causing the water to have to work harder to boil. So if it works harder to boil, it boils at a slightly higher temperature, causing your pasta to cook just a little bit faster. So turning over to the back, concentration and solubility. You see that a solution can be dilute or concentrated. Take a moment to write that down. A dilute solution is weak. So a small amount of solute, for example, that might be iced tea that you put a very small amount of sugar in. A concentrated solution is a large amount of solute. That would be a strong solution, like a very, very strong tea. A solution can also be saturated or unsaturated. Take a moment to write these down. A saturated solution means that no more of the solute can be dissolved and it settles to the bottom. For example, if you're putting that sugar in your tea and you put too much in and it all sinks to the bottom and your tea's not sweet enough until you get to the end where all that sugar is. Unsaturated means that more solute can be dissolved and there's none sitting at the bottom. So that would be your tea before you've put too much sugar in it. All right, solubility. Take a minute to write down the definition of solubility. Four-year-old wrote it. Solubility is a measure of how well a solute can dissolve in a solvent at a given temperature. So solubility can be used to identify unknown substances. So let's say we have 100 milliliters of water at 0 degrees Celsius. We could use solubility to try to identify what something is. We could take a little bit of salt and see, well, how much salt will dissolve in there before it becomes saturated, or how much baking soda. So what this chart means is that it looks like 35.7 grams of salt will dissolve in 100 milliliters of water at 0 degrees Celsius before it gets saturated and starts to sink to the bottom. You can see there is just an insane amount of sugar that will dissolve before something becomes saturated. So take a moment to think about, looking at this chart, which is the most water soluble and which one of these things is the least water soluble.